Okay, last video. This problem carries over from the previous problem. So I wrote down some key information that we're going to need from that problem in order to get this one right. In order to get that one right, or this one right, you really needed to get that last one right too. So we need to find a whole bunch of stuff here out about this graph, or has to graph it. So I have it written in two different forms here. We have it in factored form here, and we have it in standard form here. So we need to get the x-intercepts, and we know that there must be 3 since it's to the third power. So this is going to have 3 answers, and let's just get those right now. So in factored form, it's easy to spot the x-intercepts. It's what would make it 0. So I see right here the number 2, right here the number 1, and right here the number -1. And the best way to write those, I would probably count it correct if you left it like that, but as an ordered pair, that would be 2, 0, and that would be 1, 0, and that would be -1, 0. So that's where this dot, I'll switch back to pink so you can see it better. That's where this dot and that dot comes from. Okay, we're also asked to find the y-intercept. So the y-intercept. So remember, when we find the y-intercept, what's x equal to? X is equal to 0. So I would look here. You could use either form. As long as you plug in 0 for x, you're going to get the y-intercept. That could be in factored or standard, but it's much easier to spot in standard. So it's like, what would y be when I put 0 in all these places? Well, it would cancel this one out and this one out and this one out, and it's always the standard, or the constant, which is 6. So that means that my y-intercept, I'll switch back to pink, is right here. So I'd start by making all those dots first before I start thinking about what this graph looks like. So again, when x was 0, y was 6. Okay, you got at least partial credit if you got all those dots. Now we got to think about what direction it's going in. Well, it has a degree of 3. And remember, this is 3x cubed. So it's positive. So we start thinking about, okay, well, what's something cubed look like on its graph? It looks like this, right? So as this graph approaches -infinity on x, it goes down. And when it approaches positive infinity on x, it goes up. So I know that it's going to come down through these two. Like that. It's got to come back down here to touch these two. Now you didn't have to figure out this point here, okay, whatever it is. I'm not even sure that's right at this moment. I don't want to figure that out right now, but you don't need it, okay? All you needed was the end behavior, the x-intercepts and the y-intercept, but yeah, it comes down, and then it's going to come back up, and it's going to go in this direction because it's to the third power. Label each function as even or odd. Oh, this was one of the tougher ones on the test for us. So I bet now that I've talked about it in the previous 2 videos, I might pause it here and see if you guys, well, shoot, I guess it's written on the screen because this person got it right. But honestly, I think a majority of us probably missed this one. This one is neither. Why is it neither? It's not symmetrical on the y-axis, okay? And it's certainly not odd, right? If it were odd, here's what would happen, okay? I would take a point right here on this graph, and that's the point 2, 1. Okay, so if I have my little tables here, this graph includes 2, 1. If it was odd, then we would have -2, what? This would show me you understand it. I would have -2, -1. Right? That means that this graph would go through -2, -1. Does this graph go through there? No, not even close. So that's why it's neither. Well, we could say, is it even? Well, we already talked about how it's not symmetrical on the y-axis. But what would this value be if it was even? This value would be -2, 1. Does this graph go through -2? Oh, wait, that's a 3. It's not going to matter. Shoot. I don't want to stop the video now. But I just realized that this point right here, if that's 2 and that's 4, that must be 3. Again, it's not gonna matter. But that's 3. So that would be -3. Still, it's not gonna work, right? Because -3, 1, it's not on the graph either. So this one is neither. And then when I look over here at this one, first thing I always look for if it's nice enough to give me a graph is if it's symmetrical on the y-axis. If it was, this would reflect over to here, and the graph is not right here, okay? So it's not symmetrical on the y-axis, but maybe it's odd. So I plug in some test points, okay? Shoot, I'm getting an important call, so I'm gonna have to stop this and start again.